Today we are going to discuss about introduction to artificial intelligence. The overview of the session is introduction, then we'll talk about the definitions of artificial intelligence, then we'll talk about the cognitive quadrant framework, that is the different approaches to AI. In that we will be talking about systems that think like human, act like human, system that think rationally and act rationally. This is what the discussion is about. So first, to move on, what is artificial intelligence? So it is the branch of computer science concerned with making computers behave like humans. So there are multiple definitions in different textbooks. Major textbooks define AI as the study and design of intelligent agents. What are intelligent agents? Intelligent agents is a system that perceives the environment and take actions which maximizes the chance of success. That is called as intelligent agent. John McCarthy coined the term in 1956, and he defined AI as a science and engineering of making intelligent machines, especially intelligent computer programs. So, from this, what is our understanding? AI was formally born in 1956 and was coined by John McCarthy, and there are different definitions. Some focus on human behavior, others on rational reasoning. So, now a question: do you think AI needs to think like a human or not? Think of it. Now, we will proceed with the approaches of artificial intelligence, that is the cognitive quadrant. So, it is a classical way to organize AI definitions in a 2 cross 2 cognitive quadrant. This was already introduced in the leading textbooks of Russell and Peter Norvig. This framework maps thinking versus behavior against human versus rational standards. So, we will talk about each of this approach one by one. First, we will think or we'll talk about systems that think like humans. Basically, here we will be talking about the cognitive modeling. So, before going in and discussing, here we will discuss some of the definition. First definition is by Hoagland: the exciting new effort to make computers think and machines with minds in full and literal sense. The second definition is given by Bellman: the automation of activities that we associate with human thinking, activities such as decision making, problem solving, and learning. So, these are the different definitions towards systems that think like humans. Okay. So, before we go in and develop a system, first we should understand how or what's happening inside the human brain. How does a human brain work or think? So, this gave birth to two different methods. One is introspection, and another one is psychological experiments. So, this pave way for cognitive science. What is the limitation over here? Humans are not always rational. So modeling something like a human is always a very great challenge. Okay. Next, we will discuss the next quadrant, system that act like humans. Here, basically, we'll be talking about the famous Turing test, okay, approach, right? So, before going in and discussing the system that act like humans, we will see the definitions. The art of creating machines that perform functions that require intelligence when performed by people, given by Kurzweil. The study of how to make computers do things at the moment the people are better. So this was given by Rich and Knight. So here, to understand the system that act like humans, we should understand the Turing test approach. So what's a Turing test approach? Imagine you are entering a room and there is a computer terminal like here. Okay. You have a fixed period of time. Okay. And to type into the terminal, and you can study the replies that you get into the terminal. Now at the other end of this line, it can be either a human being or a computer system. Now, if it is a computer system and at the end of this interrogation, you cannot reliably determine whether it is a system or a human. Now, if you are here and if you are not able to determine whether it is a system or human, then the system is deemed to be intelligent. So, this is how the system that acts like human. To understand it, we should know the Turing test. Okay. The Turing test approach was proposed by Alan Turing in 1950. So, what was the setup there? A human interrogator or a questioner, okay, sits in a room with a computer terminal. On the other end, it is a human or a computer. The interrogator cannot see on the other side, okay. So, it's a remote communication. The interrogator types questions and reads the replies. After a fixed time, the interrogator must determine whether the other side is a human or a machine. If the computer, now the computer must behave intelligently, such that the human cannot find out. Okay. If the computer tries to fool the interrogator, then it is considered to be intelligent. Thus, that is the Turing test approach. But to handle this and to prove or to for the system to be to for the system to prove intelligent, sorry, what the computer must demonstrate. So the cognitive skills or tasks include natural language processing, communicate fluently with human being. Okay, for that it needs natural language processing. Next is knowledge representation. So for this, by knowledge representation, so store and retrieve information effectively and efficiently. Then there should be automated reasoning to retrieve and answer questions using the stored data. Finally, the machine learning to adapt to new situations and circumstances and to generalize from the past. Now, the total Turing test includes a video signal to assess perception abilities. It avoids direct physical interaction between the interrogator and the computer. So, as physical simulation, it is not required for intelligence. It allows the interrogator to pass physical objects through a hatch for interaction. The computer must be able to perceive, very important, and interpret visual physical inputs. So it should respond appropriately to physical interactions. So to pass this total test, and the computer needs both intelligence and communication and human like perception and action. So to pass that test, it needs more skills. So it should have the skill of computer vision to perceive and understand objects, that is seeing, robotics, to interact with and move the objects in the physical world. If all these are there, then the computer can prove it to be intelligent. Next, we will discuss about system that think rationally. Next, that was the third quadrant actually we are discussing about. Okay, that's the law of thought. Okay, here if you see, we have a few definitions here. That is the study of mental facilities through the use of computational models. Because we are talking about laws of thought, right? Was Charnak and McDermott. The study of computations that make it possible to perceive, reason, and act. This was given by Winston. So, what all these things tell us? Humans are always not rational, cannot be even rational. So, when I say rational, whether the rationalism can be defined in terms of logic. Think about that. Okay. And when I talk about logic, it cannot express everything, as in real world there will be lot of uncertainties. Real world is full of uncertainties. How will you represent everything? And also, it's not feasible in terms of computation times, because it needs proper guidance. Without proper guidance, we cannot even define it properly. Okay. Think of this syllogism. It's a pattern reasoning. Okay. Thinking rationally, it's about the law of thought approach. Focuses on correct reasoning process to arrive at valid conclusion. So Aristotle was among the first to codify the correct reasoning. Okay, here we can see Aristotle. He was the first to codify the correct reasoning through the syllogism. What is syllogism? It is a pattern of reasoning where conclusion is logically derived from two premises. Okay. Let us take this example of Socrates. So if I have two premises saying Socrates is a man, all men are mortal. So I can arrive at a conclusion, Socrates is mortal. So this is a syllogism pattern. Okay. Now, this Greek philosopher syllogism provides a pattern for argument structures that always yields correct conclusions when given correct premises. Very, very important. Okay. So, but what are the two major obstacles here? That's very important, right? What are the two major obstacles? One is converting the informal and uncertain real world knowledge into exact logical notation. That's what we were discussing in the previous slide. And logical reasoning is computationally expensive. That's also impractical without proper guidance. So these are the real obstacles that is being faced. Okay. So with this thought process, so what is this logic? Logic is a field of that studies rules of correct thinking and reasoning. It studies the rules of correct thinking and reasoning. Logistics refers to the tradition in AI that uses formal logic to build intelligent systems. If you see in 19th century, logicians developed precise symbolic notations to represent knowledge and relationship. In 1965, programs could theoretically solve any problem expressed as logical notation. So what are some of the key terms? So who's an agent? What was discussed here? Agent is an entity that perceives its environment and take actions. Who is a rational agent? Rational agent is an agent that acts to achieve the best possible outcome based on reasoning. So it's a very important difference, agent and rational agent. So what is syllogism? In last slide we saw that. The reason pattern, how to reason, it is called a syllogism based on patterns. So a conclusion can be arrived or derived from two premises. Okay. Now there are obstacles when we talk about this law of thought approach. Two obstacles. Obstacle number one, formalization problem. So it is very, very difficult to convert the real world situations, that is informal and uncertain knowledge, into exact logical form. Already we discussed, real world situations are involved with lot of uncertainties. Obstacle 2. What is obstacle 2? Practical limitations, that is a computational complexity. So when I have to do some logical reasoning, the computational resources requirement is very, very large. So it is not at all possible without a proper expert guidance. So these are the obstacles with respect to laws of thought. Next, we will discuss the final quadrant, system that acts rationally. So already we have discussed who is a rational agent. So rational agent tries to maximizes the success. Okay. Now, what is a rational behavior? Rational behavior is nothing but doing the right thing. What is doing the right thing? Doing the right thing means, or it is defined as, that which is expected to maximize the goal achievement given the available information. Even giving answers to a question is something called as acting. The rational agent framework generally does not rely on or does not require, what it does not require? Replications of human thought process, making the same decisions as humans, using pure logical reasoning in all situations. So these are not necessary for a rational agent framework. So this makes a rational agent framework more flexible and more powerful than other approaches. Okay. Now, what is the role of logic in rational agent? Logic is only a part of a rational agent. Okay, logic is only a part of the rational agent, not the entire or the not entirely about the it's about the rationality. It's only a part. Sometimes logic alone cannot arrive at correct conclusions. Already we discussed. Trying to represent a real world problem has a lot of uncertainties. So representing the real world uncertainties in logic is very, very difficult. So at that point of time, if we have something called as domain specific knowledge, which will be used to fill the gaps whenever the logic falls short. So this compensation or this compensates for incorrectly reasoned conclusion and covers a wide range of real world problems. Next, we will talk about the advantages. More general than a logic only system. Only if we have a logic only system, having general logic only system, it's not advantageous actually. When you combine this logic with the domain specific knowledge, then it's going to be powerful. So it allows extension with more scientific methodologies like probability, statistics, and optimization. It is better suited to the real world problems that involves uncertainty and incomplete information. So this forms the basis of modern AI systems like recommendation engines, self-driving cars, game playing agents, and more. So what we studied in this overall session, we talked about the four quadrant approach, system that think like humans, system that think rationally, system that acts like humans, and system that acts rationally. And each had its own approach, and this is where we learnt about what exactly AI means with the help of the four quadrant approach. So these are the references. The references are from Stuart Russell and Peter Norvig and then Parag Kulkarni. Thank you so much.